Hello, students. So let's actually do a little bit of probability now. We know how to detect whether something is a flush, so one thing that I could do is I could see how many tries it takes until I get a flush, right? I know that I can get a sample by typing sample dec 5. So that gives me a sample. So what I could do is I could repeat doing this over and over again until one of them turns out to be a flush. So let's write some code that does that. And I could say, hey, let's do that here, or I'll say, while hand, or while it's not a flush, I can just write over hand. Hand equals a new sample dec 5. Now, of course, this is going to have a problem because I didn't give a hand before. But if I start off with a hand that's not a flush, that'll fix that issue. So we have a hand. And what happened was this ran until I got a flush. And let's see what my hand is. Well, you can see it's a flush. It's all clubs. I could do this. Now, if I do this again, I'm going to get the same hand because, you know, it was already a flush, my hand. But now I went back to a new sample here, which probably was not a flush. And now let's see. I got a new hand of cards, which was this hand right here. And you can see because this is a sample, I'm never going to get the same card twice. I don't have to worry about getting two eight of hearts in my deck. Okay, now you might think, okay, this doesn't help me count anything, right? Because I don't know how long it took to get that flush. Python moves very fast. Could get unlucky and take longer, maybe not. So what I could do is I could say trials equals 0. And I could start with a particular hand that's not a flush to just make sure. Like I could start off with, say, my hand is equal to this and force this to be a spade. So I'm starting off with something that's not a hand. That's with 0 trials, so that's not going to affect my numbers. And then what I'm going to do is I'm going to trials plus equal 1. So what we're doing is, hey, I start off with something that's not a hand. It checks to see if it's hand. The first time, no. So what it's going to do is it's going to do a sample, a new 5-card hand, and then it's going to add 1 to the trial. So on the first trial, it's going to check to see whether that hand I just created is a flush. And then I do that again and again and again. Each time I increase trials plus 1 by plus 1. So let's see what I have for trials. It took me 209 tries. And what was my hand? I have that. So let's try this again. And let's try trials. That time it only took me 94 tries. And 210 tries, 972 tries. So I'm getting a lot of diversity here. So maybe I want to see, like, overall, how many times does it take? So what I could do is I could make a list of all of these trial numbers. So let's try that. So let's run this. Well, I'm going to make a function that doesn't take in anything because, I mean, I have to write the function. I can't just name the function, but I'm going to make a function that just doesn't take in anything. And what I'm going to do is I'm going to run this maybe 1,000 times. So what I'm going to do is I'm going to come up with this. I have my trial list. This is very imperative. And what I'm going to do is I'm going to copy all of this over to here. So I run this, and then I'm going to do this. I want to do this over and over again 1,000 times. So I will put all of this in a for loop. And now what I'm going to do is, after each time I successfully get a flush, I'm going to add the number of trials to my trial list. So trial list, append trials. And then I'm going to return the trial list. Okay, well that's a lot of information. Don't you think that's going to be 1,000 different numbers? I might not really want that. What I could do is I could return the trial list. Let's take the average of those numbers in the list. So I could take the sum of that over 1,000. And then I can run test flushes and see what happens. And it might take a little while because I'm running this quite a few times. So on average, it's taking 549 tries. Now, of course, if I wanted to do this not with 1,000, I can make this so that it runs with any number. So it's going to run this n times and take the average. So now let's say I do this 10 times. I have to run this. Unfortunately, I will get a float. Oh, I have to change this to n as well. There we go. So that time took me 692, 568. You see, I'm not getting as much variance if I do 10, but if I do 100, I'm going to get less variance. These are going to be more similar. You see, it's going to take, well, I'm getting numbers in the 400s and the 500s most of the time. And if I go to 1,000, I'm going to get even less variance than that. Sometimes it takes a little long. So I'm getting numbers pretty close to 500, it looks like. A little bit different. Okay. What if we wanted to do things exactly? We could try that next. There is an itertools library. Import choice. Not choice, sorry, combinations. Choice is what we already had. So what combinations does is it gives us all the combinations. So for instance, if I wanted to let, and just for an example, let C equal combinations of deck 5. What I could do is I could ask for the length of C, and what this is, oh, C is still a generator. So I have to make this into something that has a size. And this is telling me the number of 5-card hands. And now this has no probability in it whatsoever. Each time I run this, what it's going to give me is it's going to give me every possible 5-card hand from my deck. And of course, all of this works when you're not dealing with cards as well. It works with any mathematical object. So, okay, let's try to do this. I want to know how long it takes to get a flush on average. So what I could do is I could say, okay, well, how many flushes are there in the list? So let's see. What I could do is I could say, give me the list of all hands for hand in combinations deck 5 if is flush hand. And this is going to be a lot of information too. So I don't really like that. So one thing I could do is I could ask for the length of this list. That's going to hold this whole list in memory at once, which is not too bad. I mean, it's got 2,500,000 things in it. Python can deal with that. Another thing, if I want the length of this, what I could do is I could just say sum1 for each hand that is a flush. So basically now I'm just starting with 0 and I'm adding 1 each time. Let me write that properly. I'm adding 1 each time it finds a flush. So it's telling me out of this many possible hands, there is this many flushes. So let's see what ratio that would be. Well, divided by 5,148. And that is 504.84.84. And if you look at the kind of numbers we were getting with these trials, we were getting numbers that are very, very close to that with 1,000 tries. Sometimes a little more, sometimes a little less.